Right, a little telephone call interruption there. Number 3, we're just finishing up number 3. All right. Here's number 4. Again, I am taking the antiderivative of sine 4x. So I take the derivative of what to get sine? That would be negative cosine. And again, I'm doing the opposite. So if I was taking the derivative of 4x, I would multiply by 4. So instead, I multiply by a quarter. Negative 3/4 cosine 4x plus c. You can always take the derivative of that, and you will, in fact, get 3 sine 4x. All right, that page finished. Next page, so we continue. In fact, we have one more here with no bounds. So I can put that 2, it has no x on. I can put it on the inside or on the outside there. It makes no difference. So what is the antiderivative of e to the 3x? It would be e to the 3x instead of multiplying by 3, which is the derivative of 3x, multiply by 1/3. 2 times 1/3 is 2/3 e to the 3x plus c. Okay, so note, none of those had bounds. That's why they're called indefinite integrals. Definite integrals have bounds, okay? So I have a bound from a to b, and I am, this is what I'm going to take the antiderivative, f of x. The independent variable is x, so that's why it's dx. What I do is I take the antiderivative, capital F, evaluated at b, and I subtract the antiderivative evaluated at a, and I get some number. Okay, area under the curve, area bounded by something, that's what we're talking about here. All right, so 2 over x minus x, that is 2 times 1 over x. The antiderivative of 1 over x is natural log x. 2 on the outside minus x squared over 2. I take the antiderivative, evaluate it at 4, then 1. So I plug 4 in for x there and there. And then minus, I plug the lower bound in for x there and there. Clean up time, 4 squared over 2, that's 8. I'm subtracting it. Natural log 1 is 0, so I'm subtracting negative 1/2. I'm adding a half. 2 natural log 4 minus 15 over 2 from algebra 2. This 2 on the outside can be written as an exponent, natural log of 4 squared, or natural log 16 as well. You can write that as. All right, so I'm just I'm adding in some arithmetic, and sometimes it might be a lot of arithmetic into this. All right, so I take the antiderivative of 3e to the 2x. That is 3e to the 2x. Then instead of multiplying by 2, I multiply by 1/2. There's my antiderivative. I plug 1 in for x, and I subtract its evaluation when negative 1 is plugged in for x. So 3e to the 2 times 1, 2, minus, 3 over 2e to the negative 2. Then a very similar one here on 8s. This time I got that coefficient, I got 1/2 on the outside. So the antiderivative here would be 1/2 e to the 3x times 1/3. Again, if I were taking the derivative, I'd multiply by 3, multiply by 1/3. 1/2 times 1/3 is a 1/6. All right, I'm going to plug 2 in for x. 1/6 e to the 6th minus 1/6 e to the 0. E to the 0 is 1. 1/6 e to the 6th minus the 6th is my answer. All right, so let's just continue on here. Number 9, I'm going to integrate from negative 1 to 1, x to the 3rd minus 3x squared plus 8. 1 power up divided by the new power. 1 power up divided by the new power. 1 power up. New power is 1. Plug 1 in for x. That's 1/4. Minus, I cleaned this up first. I cleaned that up. Then I plug 1 in. I got 1/4. Minus 1 plus 8. Minus, plug 1 in. It's still 1/4. Plus 1 this time, minus 8. Here's how I like to combine them. I think I made a boo-boo here. Yeah, so nope. Hey, boss.